is Annette Clewett, and I'm with the IBM Storage Fusion development team. Today I want to show you how to do OpenShift application disaster recovery with Red Hat Advanced Cluster Management in a metropolitan area. So the diagram shows what I'm going to demonstrate. We have two OpenShift clusters that are called the managed clusters. They're managed on a third OpenShift cluster that has Red Hat Advanced Cluster Management installed. And to start with, the application will be running on Data Center 1, and we're going to recover it after a disaster to Data Center 2. For the storage, we're using an external Ceph cluster that is doing synchronous replication. It is a single storage cluster stretched between the two locations with the OpenShift clusters. In addition, there's a third location which has an arbiter or a tiebreaker that'll be used if we lose half of the storage. The thing to note with this configuration is the two sites need to not be more than 10 milliseconds apart. So now let's go to the OpenShift clusters. One thing that we can see here are the two managed clusters, Cluster 1, Cluster 2, that we're going to deploy the application to and then fail the application from Cluster 1 to Cluster 2. So going into applications, I need to create a new application via subscription. And the application I'm going to create is called IBM MQ. And I'm going to put it in a namespace called demo-dr. Going to use a Helm chart that I am publishing at my own fork here. And the name of the chart is IBM-MQ. And initially, we're going to place it, as I said, on Cluster 1. So we'll create the application. And we can watch it in a few ways. Let's go ahead to a terminal view. So what we have in our terminal view is on the top, we have Cluster 1, then followed below it Cluster 2, and below that is a hub cluster. So let me go to the project that we just created. And then see if we have any resources running yet. And we do. So I can tell that it is completely installed. So let's go back now to the ACM view, and we can see that everything is green check. So I have the application here. This is the route to the application. And it looks like we can now log in. So let's go ahead and do that. Okay. So in order to show that our data persists after a failover, we need to create a queue to put some messages in. So I'm going to go to create a queue, local queue, and custom create. And the name I'm going to give it is dev.dr.test. One more change to make here, and that's why I use custom queue, is I need to change the data to persist. So when we write messages to the queue, they'll actually be written to the storage so that we can fail over and still have our data. So let's go ahead and create that queue. And we'll just look at it real quick. Make sure it's here. There it is. Okay. So the next thing we want to do is go ahead and apply a data policy for disaster recovery to this application. To do that, we go back to the ACM console, go to Data Services, Data Policies, and I already have a data policy here that I created earlier. I named it the two clusters that are going to protect each other. So applications on cluster 1 can be failed over to cluster 2 and vice versa. And this is a synchronous relationship for the storage. So let's go ahead and apply the DR policy. So we immediately see our application here is available. And I need to put a label. I know the label that is on the PVCs in OpenShift. Let me just check it here, app.kubernetes.io/name equals IB-MQ. So this label is on every PVC that we saw in the terminal view. So I'll apply it. So this is adding the disaster recovery custom resources to the demo-dr namespace and preparing the application to be able to be failed over. It isn't failed over at this point. We're just adding the ability to failed over by assigning a data policy. So now, in order to test the failover, let's go ahead and start some messages. So we'll go to back to the terminal view. And I have a little application here that I put together to write some messages into our new queue. We'll just start that up. Okay, let's go ahead now and go back to the queue and see if we can see the messages. Okay, and we can. So these are just going to continue as long as the application is online. What we want to do now is do a failover. And we have, in this case, the ability to failed over by taking the cluster down. So I'm going to basically take all the nodes down in cluster 1. So let's go ahead and just take one more look at our messages coming in. We're up to 32. So let's do a, go back to the terminal view. I have an API into VMware. I need to get the syntax for that. So we're going to use this one right here to turn off all the nodes. I already prepared this with the node names. So let's just do that. Okay. And in a short time here, we should see that it's turning all the nodes off where the application is installed. And that's, you know, we're trying to simulate an actual disaster here, and it's going to turn all the virtual machines off. And in a short time, over on this, we should see that our messages start getting an error code. And we do see this non-2x means that it's not getting a 200 anymore. The other thing we notice is that the message is not advancing. Okay. So now if we were to try to look at the application, it's going to show that it's down. So we need to add fencing to make sure that there are no writes to the storage from the cluster that's down, even if the nodes come back up. So what I'm going to do to make it easier to see, I'm just going to pull this up and we'll clear. And I'm going to edit a resource here called DR cluster. go down to spec. And we'll go ahead and change this to fenced. Okay. So as soon as I do that, let me pull this back down so we can see cluster 2. As soon as I do that, if we go over here, this is our ceph cluster, and I do a ceph command called block list, and I'll grep for, there they are. So we just added these. These are the IP addresses of the nodes, the OpenShift nodes for cluster 1. So in addition to turning them off, we've now blocked any of the nodes from talking to the storage. So I think we're ready to fail over now. So let's go back to console. And we'll go to here. So to fail over, now that we've got it set up, we want to recover to our second cluster, cluster 2. So what we can do is go to failover, and we're going to select the policy. We're going to select the cluster we want to go to. And in this case, our application is already selected. So let's initiate. And then let's go back to our terminal. And what we can do here is we can do a watch on OC get pods pvc-n demo-dr and see if our application starts running here. So nothing here so far. We can also look at something at the hub cluster called the DR placement control, which is shortened to DRPC -o wide in -n demo-dr. And we're starting to see, even before we got the DR placement control in the hub, we can see that our application is starting to be created on the second cluster now. And it looks like it's actually running. We can check that in a few places, and then we'll go to the application. On the top here, we can still see that our message is stuck at 89. That is, the application has been out for that amount of time. So let's go to our console. Okay. We'll close this. Go back to the application. Go to the topology. So one thing we notice here, there we go. So we are now on cluster 2, and cluster 1, even though it's down, the application is now running. So let's go back here, refresh. We'll have to log in again. Okay. So again, we're running this now on cluster 2. Let's go to our queue. Here it is right here. So let's go to 50. Okay. Time that the application was down. It says 12:19 to 12:32. We did not lose any messages. So really the time difference here is just really due to the application being down. As soon as the application came back up on the second cluster, it started again with the next iteration or the next message number, which was 89. So for this failover, we've showed that even with the cluster completely down, we are able to recover the application to the second cluster with no data loss whatsoever. So now that the MQ application is running on cluster 2, how can we get it back running on cluster 1? The first thing is we need to bring cluster 1 back online. We need to unfence to the storage, and then we can do something called relocate. So let's take a look at cluster 1. So I went ahead and restarted the nodes. It takes a little while to bring everything back online. And I also am checking to see if all the pods are online. And this query just looks for any pods that are not completed or running, and it looks like they're all up. So I think we are ready to do a relocate. The first thing we want to do is put a watch here so that we can see when the application comes back. So we're going to put a watch for pods and PVCs in the namespace. Right now there are none. And on the bottom, we're looking at the DR placement control. We can see the preferred cluster is cluster 1. The failover cluster is cluster 2 currently. And right now we are in a failed over state. Okay, so let's recall that and do a watch on that as well. Okay, so I think we're all set up now. So let's go back to our console. Now I'm going to log in again. I also cleared the queue, so when we go back to here, there's not going to be any messages. I cleared it because it has a queue depth of 5,000 and it was getting close, so I just basically deleted the messages. So right now, the storage will reflect that there are no messages in the queue. We're basically starting over. So let's go back to our terminal and let's start the messages again. Okay. And they should be healthy right now because they're just going to cluster 2 and we haven't started the relocate. Okay, let's go here. Make sure we can see the messages coming in. Maybe wait for a little bit just to get a few more. All right, it's looking good. Okay, so to do a relocate, we're going to go back to the application in Advanced Cluster Management, go to relocate. And again, just to remember, this is when both clusters are healthy. One of the first things that's going to happen on a relocate is the application is going to be scaled or deleted. So you can't do that if you have no communication to the cluster where the application is running. So this is definitely a maintenance activity. It is not a disaster recovery. So we'll go ahead and pick the same policy. We want it to go back to cluster 1, and our application is already selected. Initiate. We can close. Let's go back to the terminal and see what's happening. So now we can see that we're back to the error state. The application has been taken down. Now, one of the things you have to do with relocate currently is you have to manually delete the PVCs. So we need to delete them before the failover will complete. So we can see right now that it says moving to secondary. And shortly here, once the PVCs are deleted, it will move to cluster 1. Okay? And on the top, we can see that in cluster 1, the application now is being created. Our messages are still failing on the right. And on the bottom, it says the progression is now completed. So the application is still coming up, but the actual recovering to cluster 1 via relocate has completed. And we're just waiting now for the application to create and come online. And the messages are not proceeding. So we're stuck at message 67. So now all the pods are running, and one of them now is the active pod, the top one, MQ-0. So let's wait a little bit more here. We can see that our messages are still failing. Actually, it looks like it just changed. Okay, let's go ahead and log in. Okay, go to our queue. All right, let's go find message 67. Go down to here, let's go to 50, see if we can find it within that range. Looks like we can. So here is 1446.51, 1449, but the main thing is here is, again, in the relocate operation, we've had an application outage, but we've lost absolutely no messages. So we started at message 66, we ended at message 67, and there was absolutely no data loss. Thank you for watching this demonstration, and see you next time.